Hello, I'm Michael Woods, Chief Scientist at the Asian Turfgrass Center. Welcome to another ATC Doublecut. I'm going to talk about some of the work that I did in Spain at the Catalunya Championship in this particular episode of the ATC Doublecut. If you watched or listened to the last one, I was also at home, and I'm at home at my home office in southern Thailand today recording this. And that one I recorded a couple weeks ago, just before I'd taken the trip to Spain. And I'm going to talk about the seminar that I gave there and about some of the tournament data, the playability measurements that I made on the putting greens. I'll explain some of the tools that I used and how I go about making those measurements and some of the things that I find it most interesting to measure. I want to point out one thing that I can show on the ATC website. If you already get some of the ATC newsletters, then you know what they're about. There's the ATC blog post by email, and that one comes every time I update the website. I think last week I updated the website 3 times, but prior to that I hadn't updated it for a couple weeks. So you will get an email on the same day that you will get an email on the same day with the full text of whatever I've written about on the blog. If you like to get emails and if you like to be notified every time that I update the website, that's certainly an option. And then I have a couple other newsletters. I've got an MLSN newsletter, which I send out a few times a year with updates about the MLSN method, a modern method for making fertilizer recommendations for turfgrass. And there's also the ATC update, where I announce some of the upcoming conferences I'll be speaking at, share the most popular blog posts, and sometimes I'll point out some of the interesting research or articles that other people have been doing. And I guess more recently, I'll share some of the videos that people actually watched, some of the videos that I've done, or other interesting things like yesterday on Twitter, I shared that classic one from Dan Donnelly at North Shore Country Club in Chicago, where he shows the fascinating difference, or as he calls it, he said at the end of this little demonstration, he said, "That's interesting." And what he'd done, he'd had half of a fairway that was top dressed with compost and half of a fairway that was top dressed over time with sand. So one of those one side of the fairway had a layer of sand that's built up. One of the sides of the fairway had a layer of compost that was built up. And you might expect, because sand is so used so often in the turfgrass industry, you might expect that the side with sand would be firmer. But actually, by throwing a ball onto the surface and seeing how it bounced, it turns out that the side that was top dressed with compost, that side was much firmer. The side that was top dressed with sand was softer and it was wilted. And I like to share those kind of things. And that's the type of thing that is universally interesting and applicable to turfgrass management all over the world. And those are the types of things that sometimes I'll share in the ATC Update newsletter. If you're watching this, you'll see the page that I've navigated to, and I got to this page, which is subscribepage.com/ATC_newsletters. I'll put a direct link to this in the description of this show. You can see that at this page, which you can navigate to from the ATC website homepage, you can sign up here for any or all of the ATC newsletters. And even if you don't subscribe to them, I recommend you go to see the pretty pictures, and you can see one of my very interesting hairstyles when I took a trip to Japan and was signing copies of my book in Japan with I don't know how you would describe it, shaggy hair, perhaps. It was interesting, and one of those fun photos that I thought it would be fun to put on this sign up page. So if we go back to the ATC website, we'll jump right into this post where I was talking about what I talked about in our VIP tent seminar at the Catalunya Championship. I was at PGA Catalunya for the Catalunya Championship, which is an event on the DP World Tour, the European Tour. And I was, as I mentioned in the previous episode, I was very interested to go there and measure the conditions because the tournament was arranged and announced, and the venue of PGA Catalunya's stadium course was selected on very short notice. The tournament was announced in February. This was related to COVID travel restrictions in Japan and in China. And the previous week's event was the ISPS Honda Championship, which was held in Tarragona. That was previously going to be held in Japan, but for reasons of COVID travel difficulties, it wasn't feasible to hold the tournament in Japan, so it was rescheduled for Spain. And then the next week, it was going to be the China Open, which would have been somewhere in China. And because of travel difficulties, that was rescheduled in February to be held at PGA Catalunya's stadium course. Now, when you get a DP World Tour event, which is going to be on global television and have top professional players, when that tournament is announced in February and you're going to be holding that tournament in late April, then coming out of the winter, you don't have a lot of time to prepare. Your course already needs to be basically tournament ready. And fortunately, the stadium course was. I wanted to go there and make some measurements and also see for myself, record some videos, take some pictures, talk with the people managing the turf there. The superintendent of the stadium course is Alfredo Alvarez, and the director of agronomy of the property is David Bataille, and he was so kind to organize a seminar while I was there on Thursday morning as the tournament started in the VIP tent right behind the 18th green, and he invited superintendents and architects and managers from and some turfgrass consultants also from around the local area to come out and meet me. And I had a chance to talk about some of my latest research and also talk about what I was doing with my data measurements at the Catalunya Championship that week. So we did that, and what a wonderful location that was for a seminar. I'm sometimes a little bit animated when I'm talking about something that I'm passionate about, like turf grass, like some of my latest research and the very interesting measurements that I was making that week. And I had to keep my voice down a little bit because, as you see from the pictures in this blog post, there was play from the first round of the tournament. Players were finishing up on the 18th hole as we were having our seminar. So I tried to keep it quiet when the players were on the green, and then I could go back to the normal volume of my voice when the players were hitting their approach shots from the fairway. That was really wonderful. We had some delicious pastries and a very great group of people there to talk with about two things that were really closely related, which is my latest research and about the playability. And I did this kind of what do you say? I was just speaking. I didn't have slides. I just talked about this, and these of course are topics that I can talk about without really needing to refer to slides. Although in the blog post, I think it's really better in that you can see the summary slides of the data that I was collecting that week. And in fact, this tournament seminar was held on the first round of the tournament on the Thursday morning. In the blog post, which I'll put a link to in the description also, so you can click through and see these charts and see these photos. The data that I shared is the summary data for the whole week from Monday through to Sunday. And I was obviously on Thursday, I could only talk about what I'd measured up to that point on Thursday morning. So first, I started off by talking about some of my recent research, and the first thing I talked about was OM246, which is measuring the total organic matter, the total organic material in different layered depths of a root zone, typically on a putting green, although this can also be employed on approaches, on tees, and on fairways. And I explained how it was interesting that I was talking about OM246 at PGA Catalunya because I started getting interested in making these measurements and realizing what a valuable tool it would be because of a experiment that we'd done at PGA Catalunya in 2015. I had been there for a few weeks. I wanted to go to Girona and see some turf grass, do some trail running, eat at some of the fine restaurants there, and just enjoy the salubrious climate and work on writing projects. I like to take sabbaticals around the world, and I generally have a very simple routine, which is do data analyses and writing. And I do a little bit of very slow trail running or road running and check the grasses that are growing and what the landscape is like, what the what the species composition is. I like to run slow enough so that I can identify what's growing. Sometimes I'll even stop and crouch down and look at the seed heads or look at the leaves and see if I can identify what is growing by the side of the trail. And enjoy the food and the local flavors of the region. I love to do this type of thing, botanizing and writing, and I had a chance to do that back in 2015 at PGA Catalunya. And it was interesting. They were doing this hydrogen peroxide treatment, which I'd never seen before. They were doing a drench of hydrogen peroxide into the greens. And by doing that, they were able to burn up some of the soil organic material. And then if you're reducing the soil organic material by applying hydrogen peroxide, then you wouldn't have to put so much sand top dressing and you wouldn't have to do so much coring. And that was the idea for what they were doing because they're a busy resort golf course. They're a busy resort golf course that doesn't really like to close to do disruptive work. Now, I was very interested in this because I wanted to know, is this really doing anything? Are these hydrogen peroxide drench treatments actually reducing the organic matter like you say they are? So we designed an experiment with David and with Xavi Guiol, who's now the golf course superintendent in Paul's, which is a city a little bit closer to the ocean, also in Girona. We designed this experiment and they conducted it in 2015, and we collected soil samples prior to applying the hydrogen peroxide treatments, and then they collected soil samples again after collecting the hydrogen peroxide, after applying the hydrogen peroxide treatments. And this is what I explained in the seminar, was how we had very carefully designed this experiment, and I had very carefully, repeatedly communicated to the lab about what I really wanted with this particular organic matter measurement of the samples. I wanted to make sure that we measured all of the organic material and that none of the organic material was removed from the sample during the sample preparation procedure, because I knew that standard soil organic matter testing, when you do that on a soil test, the sample is already passed through a sieve, passed through a screen, all the big chunks of organic material, the thatch material and so on, gets removed already, because by definition, that's not soil organic matter, that is debris. So it all gets removed. And what actually gets measured when you do a loss on ignition test is only the smaller material, the matter that's already decomposed, the humus. Well, it turned out that when we got the results back, the numbers were too low. It was something like 1.6%, 1.7%, 1.8%, something like that in terms of organic matter. And I quickly realized all the big chunks had somehow been removed from the sample. And I checked with the lab again, and it turned out that yes, the special organic matter procedure that we were doing, even though it's not specifically in the method, it's not listed in the method that you have to pass it through a screen. In order for that method to pass a ASTM certification, all the samples by default had to pass through not a 2 millimeter sieve like a normal soil test would be, but these ones were passed through a 4 millimeter sieve, which certainly is still relatively small, and that's going to remove your fibers, your stolons and your rhizomes, any of those kind of materials, your thatch, it's not going to pass through. So that was back in 2015. We still got some useful data from that, and it still appeared that the hydrogen peroxide was reducing the organic matter in that experiment that we did, but I was never really comfortable with the test methodology that had been used. So that's one of the reasons why I got started in late 2015, going into 2016 and 2017, exploring more and more how we should test the organic material, and realizing that this already existed in New Zealand, in England, in the UK, where people were measuring total organic material by depth. And I realized, I need to start doing this type of procedure. So I did. And I told the starting story about how it was quite appropriate that we were at PGA Catalunya talking about this, because I had gotten started with it, and now I had a couple conclusions that I wanted to share about what I've learned from doing that project so far, which, let's say now it's been 7 years or so since I started with that, and really 5 years of intensive work with the OM246 method. And I summarized by saying two things that I've noticed. Number one is that even though we're testing those samples at a 0 to 2 centimeter depth, which is from the soil surface down to 0.8 inches below the surface. And so even though we're testing those at 0 to 2 centimeters and at 2 to 4 centimeters and at 4 to 6 centimeters below the soil surface, it turns out that almost all the change is happening right at the surface. Almost everything that happens with change in terms of organic matter changing from one sampling event to the next, it's all happening right at the surface. It is much more stable at the 2 to 4 centimeter depth and at the 4 to 6 centimeter depth. So that's one thing I've noticed. And then the second thing is related to that, and it's something that one can deduce from that previous observation, and that is that if the organic material in the soil is not changing very much at the 2 to 4 centimeter depth and at the 4 to 6 centimeter depth, if those values are staying relatively stable over time, even if we are not putting sand down to that depth, and I'm referring here to courses that have not put sand down to those depths. They haven't punched holes. They haven't injected sand. They haven't removed cores and filled those holes with sand in between sampling events. And yet, if they're still seeing those organic material numbers stay constant at those depths, then it really raises the question of how much sand do we need to be putting down into the root zone. And maybe we really want to just be concerned at a lot of facilities with what's happening right at the surface, with what's happening essentially in the top inch or in the top 2 centimeters of the root zone. So I talked about that, and I talked about how I like to go about collecting those samples. And then I transitioned into another type of soil testing, another one of my exciting research projects, for me at least, which is soil nutrient sampling methods and making sure that we are able to make really accurate fertilizer recommendations. This is one where, as you know, I worked with Pace Turf to develop the MLSN guidelines, which are a modern method for making fertilizer recommendations for turf grass. The MLSN guidelines ensure for whatever type of grass we're working with, whether that is sports field turf that gets a high rate of nitrogen because it needs to grow really fast and be able to withstand and recover from all the traffic that it gets, or whether it's a link style fescue fairway that gets almost no fertilizer and it has a very slow growth rate in order to provide that kind of surface. From those extremes and then everywhere in between, the MLSN method works to make a site-specific fertilizer recommendation that ensures that the grass will be supplied with all the phosphorus, all the potassium, all the calcium, all the magnesium, all of those elements, that all those essential elements. It ensures that the grass will be supplied with all that it could possibly use. So that's what the method does. But I've more recently been thinking about the sampling for that, because if you have a putting green that is built to the USGA recommended method, that's all going to be built with a homogeneous material. It's going to be built with the back right corner of the green is going to be built with the same material as the front left corner of the green. The center of the green is going to be constructed with the same material that's on the front and the back and the left and the right of the green. The material is mixed and then spread, and you have the same soil. I've often wondered how many subsamples we need to take from there, because the standard recommendation for soil sampling any turfgrass area says that you should take a minimum of 12 subsamples. We could call those cores also. You take a soil sampling tool and you go around and take a core in 12 different locations on the green at minimum. Or the same would go for a lawn. If you're sampling a lawn, you should take a minimum of 12 samples. That's what the standard recommendations are. And you mix them all together in a bucket. You put them all together. You stir them up. And from that composite sample, that's called a composite sample because it takes these different cores or these different subsamples and mixes them all together into a composite. From that composite, you are then instructed to mix it up, and from that take a sample that is of sufficient material with enough sample volume or sample mass for the laboratory to do the required tests that you're going to request. And you then send that sample to the lab. That's the standard, that's the recommended sampling method. But I've wondered about, is that enough? Maybe we should be taking 30 subsamples and mixing them together. Or maybe we should take only 3. How many of those samples do you need in order to get a representative sample? And then do you really want a representative sample? Because there are some reasons why any of our extreme values are going to be captured if we only take one sample. Then if we start taking more than one sample and mixing those all together and sampling from that, our extremely low values or our extremely high values are going to be muted somewhat. If the sample is actually very, let's say that your back left corner of the green happens to be really low in phosphorus and the rest of the green is relatively high in phosphorus. Well, if you take samples from 5 different parts of the green and mix them together, that really low value is going to be brought up. You're not going to realize how low it really is because you've mixed all the samples together and brought it back closer to an average. But we don't actually really care what the average for a green is. What we care is that we're supplying enough fertilizer. And there's two different objectives. Well, I think there's only one objective. The objective with soil nutrient analysis for turfgrass management, the routine type of soil testing that we do, the purpose is to make a fertilizer recommendation to make sure that we identify which elements are required as fertilizer, and then when they are required as fertilizer, to make sure that we get a recommendation to apply the right amount so that the grass will not have a deficiency. That's what the objective is. But the conventional soil testing sampling recommendations, the more that I've thought about this, the more that it seems that those are designed not so much towards making an optimum fertilizer recommendation, but they're designed to identify what the average value of an element would be in a sampled area. And there's a difference in there's a difference there. There's because finding the average is not the same as making a accurate fertilizer recommendation. So I've been studying this by comparing some different ways of doing the sampling and making fertilizer recommendations from it. And it turns out that in all the studies that I've done so far, which hopefully I'll be writing about them, maybe I can take a sabbatical somewhere and do a bit of writing, or do the much better strategy, the much more effective strategy of just allocating a bit of time each day and plugging away at the writing, which realistically, that's what I will be doing. Anyway, what I've found from these studies so far is that when we take a single core from an area and do a soil test on it, and then when we take a composite soil sample from that same area and do a soil test analysis on it, and then we make fertilizer recommendations based on those two different sampling methods, it turns out that the fertilizer recommendations are the same. And that means that we could sample a lot easier. We could sample, at least on putting greens, it seems to me that we could sample with just a single core and then sample multiple greens with single cores to deal with the variability issue. And we would then be able to make equally accurate fertilizer recommendations. And theoretically, we are capturing more of those extreme values, which to me is quite interesting and actually should be one of the objectives of soil testing that I think gets dampened a little bit. The oscillations, the extreme values get brought back closer to the mean when conventional sampling methods that involve compositing subsamples are used. I talked about that in the seminar. And meanwhile, we were always getting, or I was often having to pause, and we would let players putt out, and we would hear a few polite claps as they would make their pars on the difficult 18th hole. And then I would start talking again. And I talked in the next section. The third thing that I talked about for my current research was about maximizing the number of days with good playability, which was also why I was there at PGA Catalunya, because they are trying with their management to maximize the number of days with good playability by using techniques such as the hydrogen peroxide drench. They're able to minimize the sand top dressing frequency and amounts. They're able to minimize the disruptive coring practices on the greens, the cultivation. I don't think they've cored the greens there for a number of years, many years, with no core aeration. Those are creeping bentgrass greens with just a tiny bit of Poa annua in them. And the idea is, can we assess the playability and measure the number of days for any golf course in the world? Or you can also apply this technique to sporting turf or to lawns or to roadsides or whatever type of functional turf that you want to consider, consider for each day if it's meeting the standard that you want it to be at or if it's not. So we'll consider golf course putting greens. The playability might involve how the ball rolls across the surface and how the ball bounces on the surface, for example. That is something that can be assessed as the standard is being met today or it's not. So you might add up over the course of the year and say let's say you're in a tropical place that has a 365-day growing season. You can then count up the number of days. Let's say 300 days in the year meet the desired standard and 65 days in the year don't. And the idea would be to try to maximize the number of days in a year at which the conditions of the green are meeting or exceeding the standard that one sets for that particular facility. And you can set that as perfect as you want it to be, or you can be realistic for a facility that does not have the means or the ability to make the greens perfect at like just immaculate all the time. You can have a different standard for what your owner or your customers may consider good playability. So you do that, and then you look at how you can optimize the maintenance practices to do that. So if you need to verticut the greens more, or if you need to top dress the greens more to make them smoother, or perhaps you could make the greens better by doing less top dressing. You're able to look at all the work that's done and look at how that corresponds to the playability of the surfaces. And through that, you're able to make adjustments that should lead over time to maximizing the number of days with good playability for any golf course anywhere in the world, which was a nice segue into what I talked about in the other part of my presentation, which is the measurements that I was making that week at the Catalunya Championship. Now, you might think that putting greens that have never been cored for the recent few years, but I forget the number. David told me, he said he stopped counting anymore. It's something like 6 years or 7 years or 8 years. I don't remember, but definitely not last year as far as I know. I don't think the year before. I don't think the year before that either. Coring is not a regular maintenance practice there. So I brought my Clegg hammer to measure the firmness because I wanted to see when you get a tournament announced on 2 months' notice, and you're going to have some of the world's best players playing on a globally televised golf tournament, and you haven't cored those greens for multiple years, are they going to be too soft? Are there going to be issues with the playability? And also, how's the ball going to roll across the surface? Are you going to be able to get the desired green speed? Is it going to be too soft if you don't top dress constantly? If you don't have maintenance Monday and do a verticut and and a little dusting of sand top dressing frequently every 2 weeks or every week or whatever during the growing season, if you're not verticutting the greens to remove material, and if you're not adding sand to dilute the accumulation of organic matter, are you able to produce surfaces that can meet the standard requested by the European Tour? And how's it going to look on TV? That's what I was interested to measure. And so I brought my tools, the same set of tools that I typically use when I'm measuring putting green conditions for golf tournaments. And the tools that I use are, if you're watching this, you can see the picture or go to the blog post to have a look at it. I bring a Clegg hammer, and if I can talk about firmness measurements just for a moment, I don't understand why everybody in the world that's measuring firmness doesn't use this device. I've used this since I've used my own since 2011, and I had a chance to work with some of the STRI staff at the Open Championship in 2010, and was working with them and watching them use their Clegg hammer in 2010. So it's been now 12 years that I've been working with this, and I find of all the ways that you could measure firmness, there's the USGA True Firm, there's that ball bearing drop that the PGA Tour uses, and then there's this Clegg hammer. In Japan, there's something called the Yamanaka tester. I've used all of these. I've used both kinds of True Firm. The original one that you have to have a handheld computer connected to get data from, and the one by Spectrum Technologies that is a bit more affordable and that provides a number right on the machine and doesn't require a handheld computer connected to it. And I've used the PGA Tour one, and I've used the Clegg hammer. So my experience with using all of these, the Clegg hammer is the fastest, it's the easiest to use, and the number actually makes sense. And it's not that the numbers for the other ones don't make sense. They do generally, but if the Clegg hammer gives a number that makes sense, that is related to the way that the ball is reacting on the greens, and it's the fastest to use and the easiest to use, I just don't know why people keep working with these other ones that are slower, more difficult to do, and and why everybody doesn't just buy a Clegg hammer and use that. So anyway, there's my Clegg hammer. I'll show some of those measurements. I use more recently, I've been using a TDR 350, and I use 7.5 centimeter probes on that. I use a USGA stimp meter, and I have a infrared thermometer for measuring leaf temperature. I have a food thermometer that I put in the soil to a 5 centimeter depth to measure soil temperature. And I have a little Kestrel wind meter, air temperature, relative humidity meter that I use to measure the temperature. And I measure the leaf temperature, soil temperature, humidity, wind speed, and so on to document the conditions, the environmental conditions at the time that I make the measurements, because people sometimes are wondering, well, what's the effect of humidity on green speed, or what if you have a certain dew point or something? And I collect all of those information and to have that as metadata that can be accessed for the measurements that I make. So I have those tools, and then I make some pretty intensive measurements by measuring the green speed at 3 locations on a green, and I measure the firmness at 9 locations on a green, and I measure the soil moisture content at the same 9 locations on a green. And then I measure the environmental conditions, temperature, wind speed, and so on. To do all that takes about 20 minutes per green. And it's just me there making those measurements. So you can see that if it takes 20 minutes per green, I wouldn't have enough time to measure all the greens between the time that the greens are prepared for play, which is when I make the measurements, and then the time that the first player would get there. There's just not enough time for me to spend 20 minutes per green and go around the entire golf course and measure every green. So what I do is I select 3 greens generally that are typical, and I will measure the conditions on those greens, those same 3 greens throughout the week. And I'll use that as an average. And I can also look at the range of data that I've gotten on those greens. And then as I have time, I'll go measure other greens at random. And from that, I'm able to check if the measurements that I'm making on the standard greens, as we'll call them, those 3 greens that I measure repeatedly through the week, I'm able to check if the other greens on the property are falling within the expected range of values that we would get from the measurements that I'm making on the intensively managed greens. Because by making repeated measurements on more than one green, on 3 greens, we're able to do some statistics to predict what the we're able to calculate the standard deviation, and from that predict what the measurements would be on other greens. So that's what I do. And then I make charts that I provide to the golf course superintendent showing how things are changing through the week. And I measure generally in the mornings after the work has been completed to prepare the course for play, but prior to the first play arriving. And then at the end of the day, I'll go make another measurement on those same greens and see what has changed. And I do that by going after the final group is played, but before afternoon work has been done on the greens. It had rained quite a bit the previous week. So the soil water content at the start of the week at the Catalunya Championship was an average on Monday morning of 34.8%. And that got as low as 20.8% on Saturday morning. And then on Saturday, there was a bit more rain during the day, so it went back up to 23% for Sunday. But over the course of the week, the soil water content went down by about 10%. And looking at the green firmness, which I think is quite interesting, the average green firmness started at 87 when the greens were essentially saturated at the start of the week. And that is very average for a clay camera measurement. This is with the 500-gram domed head, the standard golf course firmness the golf course firmness tester from SDI in England. 87 is about the average value that I've measured of all golf courses in the world. And then as people ask what I would want for a tournament like this, and for me, something in the range of 100 to 110 would seem to be ideal for a tournament of this level. Because then if you get that level of firmness on a bent grass green, I would expect that shots from the rough, if they're hit with a mid iron from the rough, they're probably not going to stay on the green every time. A lot of them are going to bounce and release and roll over. If you're hitting a short iron from the rough and you hit it really well, you probably could keep it on the green, but the ball's not going to have backspin. It's going to land on the green and bounce forward, even if it has backspin on it. It's probably not going to spin backwards. And from the fairway, you should be able to hit your shots and be able to control them on the green. So for me, that's what I would expect for a value of about 100 to 110 on the clay firmness measurement. And that's exactly what we saw in that over the course of the week, as those greens dried down by Friday, by Thursday, it was already above 95. It was 97 and 98. And then on Saturday and on Sunday, the average clay measured on those greens was 100, 101, 102, which for me is just ideal. And I think that is quite impressive. It's impressive for me to realize that this can be accomplished without the regular core aeration and sand top dressing and filling those holes with sand that I used to preach 10 years ago, and that still remains the standard way of maintaining greens around the world, especially if one is trying to make the greens firmer. And there's this idea that somehow taking out the organic matter from the green with cores and filling those holes with sand is somehow going to make the greens firmer. And yet you can have this counter example of greens that are not cored and are not having those holes filled with sand, and they're still achieving the desired firmness levels. And that tells me that maybe we should do things in a different way, because it goes back to that idea of optimizing or maximizing the number of days in the year at which we're having the conditions meeting our desired standard. And I can tell you that when you core aerate the green and fill the hole with sand, there is some amount of time at which the greens are not meeting the standard that I think most golfers and most people who would assess the putting surface, they're not going to say that that's meeting the standard when you have holes on the green and the ball can chatter around a bit. The Tour wanted the green speed to be about 11 and a half feet, and they adjusted the work to achieve that. And it was very consistent through the week. So the morning green speed, which I show in this chart, which you can see on the website, the morning green speed is shown in red. The afternoon end of day green speed is shown in blue. And the green speed in the mornings ranged from 11.6 feet up to 11.8 feet, which is an indistinguishable difference. So it was basically the same every day of the week, and that was with a double cut with a triplex mower every morning. And the greens in the afternoon were generally not. I think there were rolls on like 2 days, but basically the greens were just double cut each morning. So that shows that the growth rate was under control and that the speed was able to be adjusted right to the level that the tour wanted. And that's with, I think there was a morning roll on Monday and then no other morning rolls through the week. And I believe there were afternoon rolls on Monday, and I would have to check my notes, maybe on, certainly on Saturday, maybe on Friday also. So perhaps this is with 4 lightweight rolls with a roller through the week. I think 1 morning roll on the Monday, and if I remember right, 3 afternoon rolls during the week. And then I was measuring the Bobble test, which, as I mentioned a couple minutes ago, if the greens have been cored, your Bobble test score is going to be pretty low. You're going to be something around 4, 5, or 6 because the ball is going to bobble. Probably. It's certainly going to chatter, and it's certainly going to snake. And that effect is going to be present for, let's say, 7 to 28 days after the event. After coring a green, certainly for the first 7 days, no matter what tine size you use, you're going to have some reduction in the Bobble test, and it could be up to 28 days. And the problem is when you try to minimize the duration of that disruption in the way that the ball rolls across the surface, which is what the Bobble test is assessing. When you try to minimize that, the duration of that disruption to the putting, the way that that's typically done is by adding extra fertilizer, adding extra nitrogen, adding fast release nitrogen so the holes will recover quickly. The problem with that is now you just created a lot more organic material in the soil, and it kind of defeats the entire purpose of what was being done. So I think that's an interesting conclusion that seems to be, well, that's the way I've been thinking recently. I mean, I guess it's a conclusion that I've come to, but I'm always open to changing my mind, and I have to be open to changing my mind because I'm recommending now in 2022 something completely different than what I recommended in 2014. In 2014, I was still making very conventional recommendations of, yes, you should do coring. Yes, you should fill the holes with sand. Yes, you should be applying quite a bit of sand to the surface to deal with this organic matter buildup. And now I've really flipped around from that, and I'm more thinking about how about we just don't let the organic matter get created in the first place? How about we minimize the growth rate, minimize the amount of organic matter that's building up in the soil, let nature do the work of decomposing that, breaking down that organic material, and let's just maximize the number of days in the year with a good putting surface. And that's where a test like the OM246 test can be so useful, because it allows one to make those changes really safely and make sure that one is doing enough. Because the OM246 test is going to tell you not only that you might be able to do less top dressing or less core aerification, it's going to highlight for you if you're not doing enough. If your organic matter keeps going up and up, and if what you're doing is is not enough, if you're not doing enough coring, not doing enough top dressing, not getting enough sand down deeper into the profile, the OM246 is going to tell you that too. It tells you if what you're doing is just right, not enough, or too much. So it's really a useful test in that way. Anyway, for the Bobble test score, anything above 8 is essentially perfect. And this was a full field event with 160 some golfers, I think, 160 some caddies, plenty of ball marks. The golf course was not closed before the tournament. I was there on the Sunday prior to the tournament, and the course was packed with resort guests. PGA Catalunya in the winter season and in the spring season is a very popular golf course, and that's a very popular area to travel to in the winter and in the spring. And the course was essentially fully booked for the weeks prior to the tournament, and because of that, it had plenty of traffic and ball marks and so on. And then the tournament came, and the pros hit the greens and during the practice rounds and during the tournament, they're very accomplished golfers. Their shots hit the greens, makes more ball marks, lots of walking around on the greens, foot traffic, and so on. So you can't quite get a 9 or a 10 score on a busy golf course like that. But anything in the morning, even without rolling in the morning, except for on the Monday, to still be able to have a Bobble test score above 8, for me, that's quite impressive. And I have a very strict eye when I'm recording the Bobble test. I'm not just going to say it's a perfect roll when I see a bit of chatter or when there's snaking. Chatter is vertical deviation in the roll, but the ball does not leave the ground. Bobble is when the ball actually leaves the ground. For example, if the greens had recently been top dressed and there's a bit of sand on the green and the ball is rolling across the surface and hits a grain of sand and you can see that the ball leaves the surface, that would be called a bobble. In the score, if you get a bobble, at least one bobble in the roll, the maximum score that I will give is a 6. With chatter is where the ball has a little bit of chatter, a little bit of deviation vertically, but it does not discernibly leave the surface of the green. And then snaking is lateral deviation, when the ball moves unprovoked, or it's provoked by some imperfection on the green to move to the left or move to the right from the way that it should be rolling. Of course, with break on the green caused by gravitational pull, that is expected, and that's considered a true roll when the ball breaks to the left or to the right because of slope. But when there is some unprovoked deviation, that is called snaking. With just a tiny bit of chatter or snaking at just one point in the roll, I will give 8. But basically a perfect roll where I can't quite tell if there was any chatter or snaking, but it's not quite perfect. It's like I'm not 100% sure it's perfect, and I can't quite tell if there was chatter or snaking, and definitely there was no bobble. So it's basically a perfect roll, but I'm not 100% sure. That gets a 9. The only time I'll give a 10 is if it's about the most perfect roll I've ever seen. And I did see a few of those at PGA Catalunya on the stadium course this past week when I was making those measurements. I did see some of those. I recorded a 10 on about 6 or 8 of the rolls that I made during the week. But these are the average values across all the greens, across all the rolls that I made. So it was quite impressive to see that without rolling, the averages could be up around 8. And I also made a video. I've got some more videos going to be coming out about this because there was a lot of fun conversation, a lot of fun observation of maintenance practices and talking about the work that was done, some of the renovation around the greenside bunkers and the greenside rough. They just did a project over the past winter to enhance all of those areas. I've got some videos coming up about that when I have the time to produce them. But one that I already did release is a special tournament edition of Kart Rides with Micah, where I talked with the stadium course superintendent, Alfredo on the preparations that they made for the Catalunya Championship. We popped out to the 17th green before the first group came through on the Sunday morning of the championship, and you'll see it was beautiful weather, a beautiful golf course with those Mediterranean pines that are quite striking off in the distance, and you'll see those all around that property, and you can see the beautiful bent grass greens that get moderate amounts of fertilizer and no coring, and you can see some of that rough and how the ball settles in that and so on. There is that that video is available with the direct link there on the website, and so it's there's a direct link to that in the blog post, and I will also be putting a link to that in the description to this video or to this podcast if you're listening to it as a podcast. I would like to thank you to listening. Thank you for watching or listening to me talk about all of this stuff. I just find it incredibly fascinating there at PGA Catalunya because they are never just quite doing the same thing. They're not doing everything the way everybody else is doing it. David likes to try to be as innovative as possible and try some different techniques. And it certainly challenged me when I went there for the first time in 2012. I'd been in Spain. I went to the Canary Islands to do some botanizing, and then I went up to Madrid and I spoke at the Spanish Greenkeepers Congress, and David invited me to come to Catalunya and do some botanizing there. So I did that at the end of 2012, and I was surprised when he was talking to me about the surfaces that they produce, and they're not really, at that time, they were not doing a lot of the type of cultivation and sand top dressing that I thought was so essential to having high quality surfaces. So that started to challenge me, that and other observations that I was making at the same time around the world. And I've continued to go back there and monitor some of the things that they've been doing. And it was so fun to be there at the Catalunya Championship, getting a chance to spend time with so many interesting people, to experience that great weather, the beautiful golf course, and take some really great measurements and just learn so much. It was a lot of fun. All right, that's been another episode of the ATC Doublecut. I will be back with more as I talk about more of the content that I've been writing about on the website and the stuff that I think is so interesting. I'm Michael Woods from Yantakau. Thank you very much.